What does it take to be a scientific pioneer? To reframe and popularize evolutionary theory. To reveal a new material and win science's most coveted prize. Or discover one of paleontology's elusive missing links. Is the key to brilliance pure talent, ego, or just plain good luck? What makes a beautiful scientific mind? Professor Richard Dawkins is amongst Britain's most outspoken and prolific scientific thinkers.
I don't think he's quite in the Oxford English Dictionary yet, but it's almost at that level.
In the 1970s, he made his name with an explosive book that turned evolutionary thinking on its head.
It was a wonderful and radical new vision set out in sparkling prose, and above it all, this wonderful, wonderful metaphor, the selfish gene.
The book propelled him into the spotlight and gave Dawkins a platform to speak out as a ferocious critic of religion.
Lord Jakobowicz is an educated man. He knows perfectly well the world was not created in 6 days.
Richard gives definitive answers to things. If you don't like those answers, you're going to find it controversial, you're not going to like him.
Sir, there could be many things that you know well, but please, in the process of it, don't be arrogant.
How did Richard Dawkins become the most influential evolutionary thinker of a generation? And how did this lead him to assume the mantle of evangelical spokesman for atheism?
Ladies and gentlemen, please welcome Professor Richard Dawkins.
Richard Dawkins' public career spans 4 decades. Since the publication of his global bestseller, The Selfish Gene, he has penned a further 10 books, written hundreds of articles, and become a well-known TV personality.
Would you please welcome Professor Richard Dawkins?
Please welcome Professor Richard Dawkins.
His message about science is simple.
I try to emphasize that science is magical in the best sense of being spellbinding, spine-crawling, exciting, magical in that sense.
His thinking is defined by logic and by an insistence on scientific evidence.
To say, I don't understand X, therefore it must be magic, or therefore it must be supernatural, it must be a miracle, that's cowardly and defeatist, lazy. And I try to rather strongly make the case against that. You have to be open and constantly questioning and using the methods of science to try to find out what's really true.
A zoologist by training, Richard Dawkins has spent a lifetime questioning the mechanisms of the natural world. As a child of keen naturalists, biology was practically in his DNA.
I grew up in what was then Nyasaland, now Malawi, until I was 7. Both my parents loved flowers when my sister and I were young, and when we went on walks, they would constantly be telling us the names of all the wildflowers, my father in Latin, my mother in English. And so we both of us had every opportunity to love nature.
Perhaps surprisingly, Richard did not share his family's passion for animals and plants.
I suppose it should have been a paradise for a young naturalist, and I did enjoy what I saw, and I loved butterflies and birds and things. But I never really developed properly into a young naturalist. I think perhaps a bit to the disappointment of my father, who always was, and his father, my grandfather. I remember on a visit to England, which we occasionally did, my grandfather looked out of the window and asked me whether I could identify a bird that was on the bird table. I hadn't the faintest idea. So I said, "Is it a chaffinch?" And grandfather was absolutely shocked that I didn't know that it was a blue-tit.
Instead, Richard showed signs of being a different kind of thinker, one who was more interested in ideas than in outdoor life.
I loved reading, and I used to read in a rather sort of clandestine way, both at school and at home. At school, I used to sort of disappear when I was supposed to be using my hands in the workshops and things like that and read. And at home, I used to sort of sneak up to my bedroom and read when I was really supposed to be out in the big outdoors.
The natural order of things came alive to Richard not through country walks, but in the pages of Hugh Lofting's Dr. Dolittle books.
Dr. Dolittle is rather like Charles Darwin on the Beagle. All the plots of the Dr. Dolittle books concern animals and animal welfare, really, and I think that really did influence me in the direction of having a great sympathy for non-human animals. When I learned about evolution, I became even more aware of the continuity, as Darwin very much was, the continuity between humans and other animals. And we are African apes, and we're rather a recent offshoot from other African apes. And so the sort of great moral and political barrier that we tend to erect around Homo sapiens, as an evolutionist I can see is not logical. And as a child, I was kind of schooled into by Dr. Dolittle.
Though Darwin's theory of natural selection would come to form the bedrock of Richard's science, as a child he did not immediately grasp it.
I'm not sure that I really got it, actually. I think I sort of misunderstood it. I didn't really think it was up to the job of explaining all of life.
It is interesting to contemplate an entangled bank, clothed with many plants of many kinds, with birds and with various insects flitting about, and to reflect that these elaborately constructed forms have all been produced by laws acting around us.
To Richard, natural selection appeared to be inadequate because Darwin's idea was so simple.
Darwin's original argument was that species produce more offspring than can survive to adulthood. And among those offspring, it's not random who survives, but larger ones survive, or ones who are somehow better fitted to survive and to reproduce do.
As the fitter individuals reproduce, their characteristics are transmitted to their young, whilst the less fit individuals perish or leave behind fewer offspring.
As those forces work through down the generations, those that have the characteristics that better enable them to survive will do so and will be more represented in the generations.
Natural selection takes place slowly, through tiny incremental changes, over vast spans of time. Richard would be in his teens before he really took this in.
It was probably my father who explained it to me so that I first got it, and then fairly gradually became aware that Darwinian natural selection really was not just big enough, but hugely big enough. I mean, it was a really gigantically good idea.
Aged 13, the bookish Richard went to Oundle School in Northamptonshire. Here he met Mr. Thomas, a teacher who would shape his approach to scientific thinking.
He was an inspired teacher. He clearly was inspired by the living world, and he spoke with great passion and poetry, really, of what a marvellous subject biology is and how much it would encompass.
Ewan Thomas taught his class to rigorously question scientific ideas. But Richard did not yet stand out amongst his classmates.
He wasn't a star pupil, but the group that I had were a lot of very able. It would be rather difficult to be a star amongst them. I think they were great fun to teach, and he was somebody who was fun to teach because he responded in the right sort of way. But he didn't look necessarily as being outstanding.
His parents became concerned that he was not applying himself enough to make the grade and get into the Oxford college they were set on.
I think I'm right in saying that 11 members of the Dawkins family went to Balliol College, Oxford, and it was my grandfather's great hope and my father's great hope that I would as well. So I was sort of automatically entered for Balliol, and my parents went to see Mr. Thomas to talk about it.
They did come to see me at where I was staying in Oundle, and I think I did say that, well, I don't think he's going to get to Balliol at this stage. He'll get into Oxford, he won't get to Balliol.
But anyway, I applied to Balliol, and Mr. Thomas had me in his house for several evenings, I think about once a week, actually, for sort of extracurricular coaching.
And then the pace seemed to change, which was what my intention had been.
Spurred on by Mr. Thomas's hothousing, Richard rose to the challenge, and in 1959 he made it to Balliol College, where he would study zoology. Here he entered a world where Darwin's theory was barely on the radar for academic biologists.
Darwin's theory has a curious history. People think of it as Darwin revealing it to the world in 1859, and then the origin sailing forth and Darwinian theory being on top of science ever since. It wasn't at all like that. It actually went through a great decline. It's sometimes called the eclipse of Darwinian theory. And that started around the time that Darwin died in 1882 and went on until really past the middle of the 20th century. And during that time, it was deeply misunderstood, often ignored and reviled, but when it was used, it was not understood how the logic of it worked.
As an undergraduate, Richard was less concerned with Darwin than with the meticulous detail of his weekly essays. He was developing a flair for writing and original thinking.
The topics we were given for our weekly essay could well have been very specialised, narrow topics, and we were given the latest research literature on that topic, went into the library, one of the finest libraries in the world, and spent a whole week immersing oneself in this topic. And I did that to such an extent that I would kind of sleep, eat and dream the topic, whatever it was. I never ever just sort of produced a textbook answer. It was always my own take on something, which I absolutely adored. My tutors, they said they loved my essays. I don't know whether they were just being nice.
His talent for refining and communicating ideas caught the eye of one tutor in particular, world-renowned animal behaviourist Nico Tinbergen.
When I do this, you know at once what I mean. The angry face, the clenched fist, convey a mood of aggression. It's a simple form of communication.
Richard graduated in 1962, and Tinbergen was so impressed by his abilities that he agreed to take Richard on as a doctoral student.
I then became a member of his group on animal behavior, and that was a big turning point in my life. I mean, before I had tutorials with Tinbergen, I'd been going to do something biochemical, which I know would not have suited me. And so I'm very, very glad that happened.
The doctoral subject Tinbergen set for Richard was the study of innate behavior in young animals, such as chicks. Richard immersed himself in the work.
At that time, the Animal Behaviour Group lived in and worked in an old Victorian house in North Oxford. It was one of those very vertical houses with 2 rooms on each floor. And my memory of Richard was as one of the sort of senior, perhaps slightly austere figures in the group, but absolutely remarkable for his clarity of thought and clarity of expression. And that was one of the things that struck me right from the very beginning.
The high spot of the week for me was the Friday night seminars, where we all gathered around, and Nico was there, and somebody gave a talk about their research. And Nico was quite relentless in his questioning.
And I can remember one of these weekly seminars where a very distinguished scientist from Bristol University called John Crook came in to give the seminar, and he got through the first sentence, and Nico stopped him and said, "What exactly do you mean by that?" whatever it is he'd said.
He never had a proper chair. He sat on an old orange box or something, chain smoking, rolling his own, chain smoking, getting up, pacing up and down, chain smoking, sitting on the old orange box, and interrupting quite frequently. Yeah, and then interrupt.
That insistence on absolute clarity of thought must have had an influence on Richard's thinking, certainly had an influence on my thinking. And so in a sense, Richard was following in the Tinbergen tradition.
I think I came away from that enormously enthused about science, about asking scientific questions, and feeling that science really was for me.
Richard had found his vocation at an exciting time. Zoologists were returning to Darwinian ideas and beginning to wrestle with the question of how natural selection really worked. They knew that evolution favored the survival and reproduction of the fittest, but the fittest what? The fittest individuals, groups, or species?
For Darwin, it was the individual. It is us, we reproduce. But in the 1960s, it became apparent that that view was not wholly adequate. It was very difficult to take that view and still account for some of the behaviors that we see out there in the natural world, especially altruistic behaviors. Behaviors where animals apparently sacrifice themselves for other animals. How could that be if individuals are programmed to survive and reproduce?
The answer for many biologists was that the fittest groups of organisms survived and reproduced. If one wildebeest behaved altruistically to take care of another wildebeest's infant, the whole group would be successful and altruism would blossom. But other biologists thought this approach illogical.
Let's imagine a hypothetical example where everybody in a group behaved altruistically, and let's say they give up their food for other people. But that one individual in that group now behaves differently, behaves selfishly. So instead of giving up food, it grabs food from others. And food translates into survival and reproduction. You play the tape forward through a few hundred generations, and what's happened? All the goody-goodies, the altruists who gave away their food, have been supplanted, replaced by the selfish individuals who scoffed the food and reproduced as a result.
An alternative theory was proposed by Bill Hamilton, an evolutionary biologist with a particular interest in social insects. He wanted to know why female worker insects take care of the colony when they have no chance of ever reproducing in their own right. He came to believe that the sterile workers were sacrificing themselves for the queen and male drones because they all contained the same genes. And he believed it was true not just of social insects, but of all biological organisms.
The main thrust was the idea that animals share genes with their relatives. So if I do something for my brother, let's say, then the genes that cause me to do it will survive in him. And so there is essentially a gene-centred process going on.
If we took a gene-centred view of the world, we could explain some of those behaviours. Because it is the case that although we have our genes aren't uniquely ours, we share them with our relatives.
What Bill Hamilton did in 1964 was to realise that what matters is not just reproduction, not just producing children, but assisting the survival of your own genes. Any gene that assists the survival of itself by working through sisters and brothers and nephews and nieces and so on, such a gene would propagate itself.
Though Bill Hamilton published his work in the mid-60s, it attracted little attention.
It was, I think, one of the most difficult papers to follow that has ever been written. So, although the paper was there, it wasn't having much impact.
But Richard, now lecturing for Tinbergen at Oxford, had found his way through Hamilton's complex mathematics, and he brought the ideas into his 1966 course notes.
I was immensely enthusiastic about it and brought it into my lectures. The 66 lectures were a eureka moment for me. I had this sort of semi-poetic vision of immortal genes manipulating mortal bodies, survival machines, as I called them, and throwing them away and then marching on down the generations. It's true. It's what happens. The thing about genes is that they're potentially immortal because they're copied and copied and copied and copied identically down through countless generations, and the bodies are thrown away.
These were ideas Richard would later immortalize in The Selfish Gene. But for now, an emerging technology kept him from getting down to writing. He was still studying behavior in chicks and was swamped in statistics. What Richard needed was a way to process the data.
He was one of the very early people into the use of computers.
In those days, there was just one computer in Oxford, and you had to submit your job on punched paper tape, and then you came back the next day or maybe 2 days later and got the results, and you found a stupid mistake which you corrected, put back the paper tape and came back with another stupid mistake and so on. So it was a very laborious business. I learned how to program and became utterly intrigued by it.
Richard was then in charge of a deep animal behavior group computer, which was about the size of a room and had about the calculating power of a mobile phone, or less than a mobile phone, in fact. But Richard was one of the very early adopters.
I remember once I dreamed that I was a computer just chugging my way through, repeating and repeating and repeating and repeating, a sort of horrible nightmare of a night. And I got up very early at dawn. But anyway, the fascination of computers stayed with me.
So I can remember Richard trying to teach all of us in the animal behavior group how to write computer programs in machine code, a string of zeros and ones. So he was a real pioneer in that field, and it reflects his logical mind and I think his interest in how things work.
I think the correct word would be addicted to computer programming, and the addiction became much worse when computers following Moore's law, became smaller and faster and cheaper, and so one could have access to one's own. And then I really did become addicted and had to more or less positively cure myself of it.
Richard was not only distracted by computers. In the late 60s, he took a lecturing post at the University of California in Berkeley. It was the height of flower power, and he soon discovered a passion for campaigning.
My first wife, Marion, and I had just got married, and we went out together for a sort of adventure in our 20s. We were, both of us, were very politically active. We got involved in the anti-Vietnam War demonstrations. We got involved in the campaigning for the Democratic candidacy for the presidency. And so our old car was simply covered with electioneering posters and things. We went to demonstrations and political meetings and things, both in Berkeley and in San Francisco. And I lectured on animal behaviour, and I suppose it's really a time of youth which sort of haunts one's dreams for some time afterwards.
But after 2 short years, Nico Tinbergen managed to lure Richard away from California, back to a research position at Oxford. The England he returned to could not have been more different from sunny California.
There had been fierce struggles between the police and pickets as the strikers tried to stop lorries entering and leaving.
Britain was in the grip of industrial unrest. A miners' strike in the early 70s brought Richard's computer work to a standstill.
There were constant power cuts, and it wasn't possible to do research that involved electrical apparatus. So I thought it would be a good idea if I tried to put together the ideas that had so inspired me in 1966 and write a book. And I started to write it. I wrote 2 chapters, but then the power came back on. And so I gave up the project and went back to my research.
But evolutionary thinking was moving fast. Like Bill Hamilton, who had inspired Richard in the 60s, other academics such as John Maynard Smith and Bob Trivers were also publishing papers about altruism and genes. Reading their work spurred Richard into action.
It was the advent of the Trivers papers and the Maynard Smith papers in 1971, 72, 73 and 74 which goaded me into finally getting back to taking out my first 2 chapters out of the drawer and getting down to it properly. I think I felt, yes, I think that's right now, it's coming back to me. I think those extra papers, I really felt, gosh, this has got to be, I've got to get back to that book. This is so exciting. There's so much to add. So I wrote it in quite a frenzy of energy.
The manuscript was finished in 1975. Now, it needed a title.
And I remember Richard ran a little competition amongst us, his friends and colleagues, for the title of the book. And my submission was Immortal Coils, which I think he used as one of the chapter headings, but he stuck with his own idea as the title of the book.
The title Richard chose was The Selfish Gene.
I called the book The Selfish Gene because if anything is a selfish entity maximising its own survival, it is the gene. You don't want to talk about the selfish organism, the selfish individual, because most of the time, not most of the time, a good bit of the time, organisms are being altruistic. They're driven to be altruistic by the selfish genes.
It was this now iconic title that appealed to publisher Michael Rogers at Oxford University Press.
So Michael asked if he could see what I was working on, and I gave him some chapters. And I was phoned up and he said, "I must have that book!" And he then, nothing would deter him. I mean, it was absolutely, it was sort of, I don't know what you'd call him, like a bull charging.
I started reading and I couldn't stop. It was so good and it was so brilliant, and I was completely, absolutely gripped, and I thought it was so wonderful. And from then on, I couldn't sleep